Hey everyone, in this video, let's take a look at question 17, letter combinations of a phone number on Leetcode. This is part of our blind 75 list of questions, so let's begin. In this question, you were given a string containing the numbers from 2 to 9 inclusive, and you want to return all possible letter combinations that the number can represent. You want to return this in any order. So we can see that a mapping is given below, where it's like the number maps to the letters, just like on a normal telephone, and we see that 1 does not map to anything. So let's take a look at the examples here to see if we can make sense of what this question is saying. I'll paste in the examples right over here. So let's take a look at this first one, right? So digits are 2 and 3. And actually, I've already prepared this mapping here. So this will be needed later on. But basically, all it's doing is just taking the telephone values and then putting them into a dictionary like this. So we'll just paste them here. Okay, so let's see what's happening here. So when you have something like 2 and 3, right? So the first thing we notice is that 2 is mapped to like A, B, and C, right? And then 3 is mapped to, looks like D, E, and F. Now, even before we start off this problem, we can note that just by the wording, return all possible. Whenever you see something like return all possible or generate all possible, where it's like an exhaustive search and you want to return many answers, you want to kind of think recursion, but actually not just recursion, backtracking type recursion. Backtracking, we've already done many videos about. We have subsets, permutations, combinations, sum. But all of these questions try to follow the same, or I try to make my answers follow the same sort of format, the same sort of answer. Like the structure of the code is almost exactly the same, and you just change a couple of things. So we're going to do this in this problem, but let's kind of see like why it's backtracking, right? I just don't want to mention it's backtracking and, you know, just leave you with that. I kind of want to like explain like why it might be backtracking here. But that's just a hint, right? Like when you see like return all possible, then consider backtracking as a possible way to do it. But let's see, when you have something like 2 and 3, right? So initially, what do we want to do? Well, we want to generate a string, right? We want to generate a string. So a string initially will just be A, right? And now what we can do is we can go ahead and recurse. What we do, we recurse on the 3, which is the next index, and we try to generate A and D, A and E, and A and F. But how does this work? So one step at a time, we'll have A, and then we'll generate A and D, right? And then after this, we still try to generate one more, right? Like we still try to go further, but we can see that we'll be like out of bounds, right? Because there's only 2 elements here, and there's only two elements in the digits, and the third one, it doesn't exist. So this is pretty much all that it is. And then what will we do? Well, then we'll go ahead and pop. We'll pop this last element, and then we'll generate A and E. Similarly, we'll try to recurse again, see that there's nothing. We'll go ahead and pop, and then we'll generate A and F. And similarly, we'll pop from here, and now we'll pop from here. And then we'll go to B, and then we'll generate B and D, and again pop, and then E, and then F, etc. And then we'll do the same thing for C. C, D, C, E, C, F. So that's kind of like how the backtracking will work here. So let's kind of take a look at how we might want to do this. And as I mentioned, I kind of have like my structure of code that I like to follow here. So I'm going to use the same logic here. But before that, let's maybe consider our simple cases where we need to, like number is empty or something like that, right? So if, let me just maybe remove all of this. So if not digits, and I'm actually just going to call it nums, just to kind of say like that, nums. So if not nums, then we'll just return an empty, right? Like we just need to return an empty. It looks like it's an empty list, so that's fine. So otherwise, what do we need to do? Well, we have a result variable. And again, this is all part of the format I like to use. I like to use result, which will store my answers. I like to use my helper function, which is my recursive backtracking function, which will fill up result. And then I like to return result in the very end. Okay, and now we have our helper function. So again, what are some of the things we pass in? This comes exactly from how we did subsets, permutations, etc. Well, we need to pass in the nums, which is like our digit string. We need to this time pass in like mapping. We'll need the mapping, which I'll just call D. I'll just keep it short, like dictionary, like D, like this. And then what else? Well, we need to pass in cur, right? Cur will essentially store like our potential answers as they grow larger and larger until we're ready to add it to a result. So I'll store in cur. What else do I need? Well, I need result. I need index because I need to know like where I am in the digits string. So if I'm here and then I do a recursive call, well, then I want to start off at the next index. So I need to do that. And again, this is all from the subsets video, permutations, etc. And I think that's pretty much all we need right now. So let's take a look at what we have. So first of all, the base case, right? So how do we know when we're ready to add to res? So let's assume that cur is one of this answer here. So cur would be something like A and then D, right? How do we know we're ready to add to res? Well, I can actually just check, right? I can check if length of cur is equal to length of what? Length of nums, right? Because there's 2 items here. There has to be 2 items here. If that's the case, then I can go ahead and add it. So I would do res.append. what do I need to append? Well, it looks like I need to append a string, right? So I would just convert this to a string using this fancy notation here, but this basically just joins it into a string, and then I will return it. Note that I'm not returning an array, so I don't have to actually do this, even though I could in this case. Sure, let's just do it to keep our consistent, but we really don't need to do it in this case. Otherwise, well, what? Well, now we need to loop, right? So let's say we're on the 0th index, right? So now we need to figure out like the two. We need to figure out all of the possible combinations from the two. So actually, one thing I could do is I can go through my array, and I won't start at 0, but I will start off at index, and I will go through the rest of the array, and now I need to find out like the possible combinations that I can map in, right? Like the thing it maps to. So I can do something like m for map, and then here I can do, or maybe I can do something like letters, right? Letters, and what is letters equal to? Is equal to d, and then d at nums at I. Well, notice that nums at I will actually be a string here, so I need to cast this to an integer. So we'll do something like this. So now we have our letters. So for example, initially when we're like at the number 2, in the 2 and 3, now we have the letters A, B, and C. So what I can do now is I can do for L in letters. Now I can basically form my sequence. So initially I have something like empty, right? Now I can form the sequence, which is just A in itself. So I will do cur.append, and it will be the letter. And again, this is exactly how we do these backtracking type problems. Cur.append. I'll do a recursive call here, which I'll fill out, and then I'll simply pop it in the very end after my recursive call is done. So what happens here? Well, num stays the same, d stays the same, cur we've already changed, result stays the same, index. What does index become? Well, we processed the 2, right? Now we want to process the 3. So in a recursive call, we will go to the next index, which in this case is I plus 1. And that's pretty much all there is to this. In the very end, we don't actually need to return anything. This function doesn't return anything. So we can just leave this as is. But we need to fill this out. So this will be nums, this will be d, this will be cur, which is like a empty list at this point, result, and then index, which we will initially start off at 0. So let's take a look and run these sample test cases. And we can see that it works. Let's go ahead and submit. And we can also see that it works. Perfect. Now, in this case, we don't actually have to use an array here. That's just simply how we like to do our problems. But because we're adding in a string, we can actually just pass in cur as a string like this, right? And then here, none of this changes, but actually this, I would just pass in cur. And similarly here, actually, here, we don't need to, we can just append to the string here, right? We can just append L here. We don't need to do any of this append and any of this pop because it is just a string. Strings don't strings don't keep their value like when you go down recursion. So we can just do it that way. So that's another approach that you can take. Anyways, this was a solution. For the time complexity, for these backtracking ones, it's always 2 to the power of something. I don't really know like what it would be in this case. You'd have to figure that out, to be honest. Space complexity kind of similar to that, but these are often like hard to calculate anyways. But yeah, I hope it helped. And yeah, remember to use this template anytime you see some sort of backtracking type problem.